Hello and welcome back to another video. In this video we are going to solve the next two questions, that is question number 5th and 6th from specimen paper for the examinations from 2020, and it is from Pure Mathematics 3, that is paper 3. So here's the question number 5th A part. Show that differentiation of x minus, that is ddx of x minus tan inverse x is x squared over 1 plus x squared. And we know that differentiation is linear. It means we can differentiate this and then subtract the differentiation of this. So left hand side become ddx of x minus ddx of tan inverse x, and this is going to be 1 minus, and we know the differentiation of tan inverse x is 1 over 1 plus x square. It is a identity. We can get this differentiation in the formula booklet MF9 also, and then we will take the LCM, and it is going to be 1 plus x square, and by cross multiplication we will get 1 into 1 plus x square, that is 1 plus x square minus 1. Now we can cancel 1 and minus 1, and we got the answer as x square over 1 plus x square. So it means ddx of x minus tan inverse x can be written as x over 1 plus x square. I hope it is clear. Let's do the B part of this question. And here's the B part. Show that integration from 0 to root 3 x tan inverse x is this. And here we have the inverse function as well as algebraic functions. So we are going to take this as the first function and this as the second function, and then we will use the integration by part. We know that it is going to be u v times dx is, and it is first function as it is, and the integration of second function with respect to x, and then minus integration of differentiation of first function ddx of first function, it is u, multiplied by integration of second function with respect to dx and whole integration. That's the integration by part. And so here we are going to rewrite this left hand side, and I'll put the limits at the last. So the left hand side become first function as it is, tan inverse of x, into the integration of second function. Integration of second function is going to be x squared divided by 2, because integration of x is x squared by 2, minus the integration of first differentiation of tan inverse x. It is going to be 1 over 1 plus x squared, and multiplied by integration of second function, that is x squared by 2. So it is x squared by 2 with respect to dx, and we can rewrite it as 1 upon 2 times x squared tan inverse x minus 1 upon 2 common, and we got integration of x squared upon 1 plus x squared with respect to dx. Now we will use the first part. In the first part we have seen the differentiation of, I will bring it there. See, in the first part we have seen the differentiation of x minus tan inverse x is x over x squared over 1 plus x squared. It means from here we can see that x squared over 1 plus x squared integration would be x minus tan inverse x. So we know that integration is just the reverse of differentiation, so it is going to be x minus tan inverse x. So we will use it here. So this become 1 over 2 x squared tan inverse x minus 1 over 2 times x minus tan inverse x, because this integration from the first part is x minus tan inverse x. Now we will put the limits from 0 to root 3. So upper limit is root 3. It become 1 upon 2 times root 3 square is 3, and tan inverse of x, tan inverse of root 3 is pi over 3, minus 1 over 2 times root x, means root x is root 3, so it is root 3 minus tan inverse of root 3 is pi by 3, and minus the lower limit. X is lower limit is 0, so 0 times tan inverse 0, we are going to get 0, minus 1 upon 2, x is 0, so it becomes 0, minus tan inverse 0 is 0 again, so we got it cancelled, that is 0 only. So we only need to solve this. 3 got cancelled, and we are left with pi by 2 minus root 3 by 2 minus minus plus, minus by 1 by 2 into minus pi by 3 is plus pi by 6, and we need to write in this form, and we have got this minus half root 3, and if we'll solve root pi by 2 into pi by 2 plus pi by 6, we can multiply by 3 in numerator denominator, and we will write it as 4 pi by 6 minus 1 by 2 root 3, or we can get the final answer 2 by 3 pi minus 1 by 2 root 3. So that's the answer we can see from here, and I hope it is clear. Let's do the next question. Here's the question number 6. The complex numbers 1 plus 3 iota and 4 plus 2 iota are denoted by u and v respectively. First part is find u over v in the form of x plus iota y, where x and y are real. So we will calculate it. U over v can be written as 1 plus 3 iota over 4 plus 2 iota, and in order to write in this form we have to multiply and divide by the complex conjugate of the denominator, that is 4 minus 2 iota upon 4 minus 2 iota, and we'll solve it. In numerator we got 1 plus 3 iota multiplied by 4 minus 2 iota whole upon, this is a plus b and a minus b, so that is going to be a square minus 2 iota whole square, so it would be 1 into 4, we'll simplify the numerator, 1 into minus 2 iota plus 4 3s are 12 iota, and minus into plus minus, but iota square would be minus 1, so it is going to be plus, and 3 2s are 6, since iota square is equal to minus 1, and denominator will also be like that. It is 16 and minus iota square, that is going to be plus, so 16 plus 4 is 20. Now we'll simplify it. 4 6 10 and plus 10 iota upon 20 here upon 20 here, so at the last we got it as 1 upon 2 plus 1 upon 2 iota. So that's the answer in the form of x plus iota y. I hope it is clear. Let's do the B part. Now here's the B part. State the argument of u over v. So since from the first part u over v is 1 by 2 plus 1 by 2 iota, so the argument of u over v would be tangent inverse of y by x, that is 1 upon 2 over 1 upon 2, that is going to be tangent inverse 1, and it is going to be pi by 4. We know that tangent inverse of 1 is pi by 4, so the argument of u over v is pi by 4. We could have directly written pi by 4 because it is like the question is state the argument of u by v. So that's the answer. Let's do the next part. And for C part, in an Argand diagram with origin O, the points A, B and C represent the complex number u, v and u minus v respectively. State fully the geometrical relationship between OC and BA. So we know from the first part and second part, first part only, that u is equal to 1 plus 3 iota and v equals 4 plus 2 iota. So from here we can calculate u minus v. It would be 1 minus 4, that is minus 3, and 3 iota minus 2 iota is going to be plus 1 iota, so it is 1. So we'll draw these values and mark it as A, B, and here it is C. Then we can see the relationship between them, between OC and BA from there. So let me do it I'll do it directly. So from here we can see this is going to be 1 plus 3 iota, so it is A, OA, this is origin, OA, and V is 4 plus 2 iota, 4 plus 2 imaginary 2 iota, this is 4 plus 2, that is B, and C is minus 3 plus iota, so minus 3 plus 1, this is going to be U minus V, that is C. So from here we can see the relationship between OC, O to C, and B to A. O to C is going rise 1 and run is 3. Again from B to A is also rise 1 and run is 3. So first thing is they are parallel. They are parallel, and we can see that they are equal as well. So we can write OC is parallel to BA, as well as OC is equals BA. So these are the two geometrical relationship between OC and BA. We can see from the diagram very clearly. So, and here is the last part, that is D part of this question. Show that angle AOB is 1/4 of pi, that is pi by 4 radians. So from the diagram we can see it was B here and it was O and this is A. So we need to find the argument of AOB, that is this angle, not argument, this angle as pi by 4. So we have this as 1 plus 3 iota and this as 4 plus 2 iota. So if we can subtract the argument of OA, this OA, like subtract the argument this angle, which is going to be argument. If we subtract this angle from the total angle, we will get this angle, and we'll show that this angle is going to be pi by 4. So angle AOB is going to be argument of U, that is OA is U only, argument of U minus argument of V, this one, so that we will get this argument. And argument of U is y by x tangent inverse of y by x, that is 3, minus tangent inverse of argument of V is again 2 by 4, y by x 2 by 4. Now we are going to calculate this from calculator, not separately, together, so that we can get this answer. And now this value from the calculator is directly 1 by 4 pi, and that's the answer. And the thing is, if we'll calculate it separately, then we will get something which is closer to it, but the value we'll get from the calculator not in pi, like tangent inverse of 3 is 1.249 and all, and tangent inverse of 1 by 2 again it is 0.4636 and all. So if we'll subtract, we'll never get exact 1 by 4 pi. So the thing is, we need to subtract it directly in the calculator and we'll get pi by 4. So that's it for this video. I hope it was of some help. So let's meet again in the next video with some other questions. Till then, thank you so much.